This question is from GATE 2017. This is on data structures. The question is, let the T be a binary search tree with 15 nodes. So T is a binary search tree with 15 nodes. So we have to determine the minimum and maximum height of this tree. It is given in the question that if a tree, that is if a BST having single node, then the height will be considered as 0. Now what we have to determine, what is the maximum and what is the minimum height of the tree with 15 nodes. Now if we have n nodes, then the maximum height of the tree can be achieved if the tree is skewed, that is if the tree is right skewed or left skewed. For example, if we have 3 nodes, suppose 1, 2 and 3, then the maximum height is possible if I draw a skewed tree, right? This is a skewed tree. So if we have 15 nodes, that means the maximum height possible will be, see, if I place 15 nodes in this way, that means this is the node 1, node 2, node 3, node 4. In this way, this is the 15th node. That means if I place these 15 nodes in a skewed tree, then we should get a height of 15 minus 1, that is 14. Why? Because height of a single node is 0. It is mentioned in the question. So if I write only a single node, that is 1, so height of this tree is considered as 0. If I add another node here, the height of this tree will be 1. If I add another node, the height of this tree will be 2, in this way. So if we have 3 nodes, then the maximum height possible is 2. Similarly, if we have 15 nodes, the maximum height possible is 14. Now in case of minimum height, when should I get a minimum height of the tree? When the binary search tree is fully complete. That means something like this. If I draw a tree in this way, then the height will be minimum. So what is the formula to compute the minimum height? The formula is log 2 n plus 1 minus 1, where n is the number of vertices. So here the value of n is 15 plus 1, that is 16, right? So log 2 16 minus 1, so log 2 16 is nothing but 4 minus 1, that is 3. So what we have obtained, the minimum height is 3 and maximum height is 14. This is your answer.